Today we're solving equations, and we have one essential question that I'm going to reiterate over and over and over again as we work through solving equations in Algebra 1. And that essential question is, what will make the equation true? That we're going to be asking over and over and over again all through this year. What will make the equation true? So, solving equation basics. An equation must stay balanced. Think about a seesaw. Think of an equation like a seesaw or a scale. And a scale is normally something that has a right side and a left side. Kind of looks like this, where we got this situation. We need the left-hand side and the right-hand side. The right-hand side must weigh the same as the left-hand side. Those are just some basics, and those are things that I'm going to continue to remind you as we work through equations. So what we're going to do first is we're going to work backwards here. So think about what we are given. If we're given that x is equal to 5, well, think about the scale. If we want our left-hand side to weigh as much as our right-hand side. So first thing I'm going to do, I'm going to draw a dashed line here, because just to remind you that this is the left and this is the right. The left-hand side of the equation, the right-hand side of the equation. So what does this equation look like if I add 10 to both sides? X plus 10, and then 5 plus 10. And think about it. I can add 10 to both sides by the addition property of equality. So I can add 10 to both sides, and that still allows my equation to remain balanced. Got a little excited there. So my equation's balanced. What if I want to double both sides? And we'll go ahead and simplify here on the right. Obviously, we can't simplify on the left because they are not like terms. So I'm just going to change this to x plus 10 equals 15. All I did was simplify there. Okay, what if I want to double both sides? And I'm allowed to double both sides because of the multiplication property of equality. So I'll do that in pink so you can see what's happening. So times 2 times 2. Now notice I'm not just doubling the x, I'm not just doubling the 10, I'm doubling the entire left side. And in order to simplify that, I'm going to need to use a property that we talked about in the properties video. Hopefully you're remembering, it is the distributive property. So when I simplify here, I'm doubling both sides. I end up with 2x plus 20 equals 30. So I just kind of transformed this equation by following the properties of algebra, working backwards from the solution, and now I've got 2x plus 20 equals 30. Now, my equation is remaining balanced, and here's how I know it's going to remain balanced, because when I plug 5 back in, does it still make the equation? And remember, the equation is a statement because it has a verb phrase in it. X is 5, 2x plus 20 is 30. So when I plug in that 5, does it still remain true? Well, let's check. So here goes. So I'm going to use the substitution property and plug in the 5. 2 times 5 plus 20 equals 30. 2 times 5 is 10. 10 plus 20 is 30, and 30 equals 30. So yes, it still remains true. My equation remained balanced. So left side, right side, I'm keeping my equal signs lined up. I'm working down the page. Now we're not going to move backwards any longer. we're going to start going forward. We are going to start by solving 2x plus 3 equals 15. And once again, I'm going to draw my line straight down from my equal sign. It's just good algebra manners to line up your equal sign and work down the page. So let's go. Now remember, we want to know what we can plug in that will make this a true statement. That's our essential question every single time that we solve an equation. So we want to start undoing what's been done to the variable. So what has been done to the variable? The variable has been multiplied by 2. Remember, that's multiplication. Even though we normally don't write an operator there, it does imply multiplication. And then, of course, we're also adding 3. Now, normally when we are solving equations, we go in the reverse order of operations. So remember, we learned that order of operations G, E, M, S. Grouping, exponents, multiplication or division, subtraction or addition in the order that it comes from left to right. But if we're solving, then we need to go in reverse. So we're going to start by undoing subtraction or addition first. So in order to do that, we need to undo plus 3. The opposite of adding 3 is subtracting 3, and we will show that to both sides. We are using the subtraction property of equality. We're subtracting 3 from both sides. We're keeping our equation balanced. The 3's cancel. We get 2x equals 12. Next thing we need to undo, we need to undo the multiplication or division. We have 2 times x. To undo times 2, we need to divide by 2. Division is the inverse operation of multiplication. We are using the division property of equality. We're keeping our equation balanced. Whatever we do to one side, we do to the other. 2 divided by 2 is 1. That leaves x all by itself. 12 divided by 2 is 6. So, will 6 make this equation true? So we're going to remember to check. We'll check it right down here at the bottom. So we're going to take that 6. We're going to plug it back in for x using the substitution property. 2 times 6 plus 3 equals 15. Just a reminder, do not use x for multiplication. X is our variable. Let's use parentheses. That's the safest bet. 2 times 6 is 12. 12 plus 3 is 15. 15 equals 15. We're correct. Let's solve again. 1/2 a plus 5 equals 18. So once again, we're going in reverse order of operations. So order of operations, GEMS. We are going to undo the addition or subtraction first. Let's get our work set up so we're ready to work down the page. Minus 5 minus 5. A positive 5 has an inverse of negative 5. That's what we're going to do to both sides. That's the subtraction property of equality to both sides of the equation. A positive 5 and a negative 5 cancels. We're left with 1/2 times a equals 13. Let's think about this. 1/2 a means exactly the same thing as a divided by 2. Consider this question. If I ask you for half of 10, half of 10 would be 5. That means exactly the same thing as 10 divided by 2. It's also 5. So if I want to undo a fraction here, my best option is not to divide by a fraction because that's messy. Think about it. The inverse of multiplying by 1/2 would be actually multiplying by 2. But that's what division by a fraction is. It's really multiplication by the reciprocal. So we are going to multiply both sides by 2, highlighting that in green parentheses there. We're going to multiply by 2 because 2, or 2 over 1, is the reciprocal of 1/2. So 2 halves make a whole. So we finally get our 1a. 13 times 2 is 26. Does 26 make this equation a true statement? Oop, I've got to write my property here. Multiplication, property of equality. Justifying my steps here on the right. Remember to check. Let's plug it back in. We're plugging it back in right there using the substitution property. 1/2 of 26 plus 5, does it equal 18? Follow order of operations. So half of 26 is 13. 13 plus 5 does indeed equal 18. Yes, our solution checks. It makes our equation true. That's what we're asking every single time. Let's solve again. So this time we have 7 minus x divided by -3 equals -10. Now, GEMS, this one's a little tricky because remember, this fraction bar is a grouping symbol. And even though normally this is our go-to if we're thinking about solving, we're going to go backwards, I prefer to think of this -10 as -10 over 1. And you learned last year in pre-algebra that when you have two fractions set equal to each other, so two fractions set equal, hopefully you learned in pre-algebra last year that you should cross multiply in order to eliminate the fractions. And that's what we have here. We have two fractions set equal. So going to set my equal signs in line here. And really what's happening when we cross multiply in this situation is we're really just multiplying in order to set the cross products equal to each other. So we want our cross products set equal to each other. So -3 times -10 is +30. I am cross multiplying over that equal sign in order to set the cross products equal to each other. So -3 times -10 is +30, and 7 minus x equal times 1. Anything times 1 is itself. 7 minus x. So we had two fractions set equal. We cross multiplied. We set the cross products equal to each other. Now from here, we can get back to going in reverse GEMS. So now we want to undo addition or subtraction. So this one's a little tricky in that, remember, 7 is positive. It's the x that is negative. And I'll show you that by reminding you that negative x means, or minus x really means plus negative x. So if we're going in reverse order of operations here, we are going to subtract 7 from both sides in order to undo the subtraction or addition first. So that is the subtraction property of equality, which leaves us with negative x equals 30 minus 7, which is 23. We don't just want negative x, we want x. So remember that negative x means negative 1x. So in order to get rid of that negative 1, I need the division property of equality here. So divide by negative 1, divide by negative 1, x equals negative 23. So we're assuming that negative 23 will make this equation true. Let's plug it back in and see if our work checks. Plugging negative 23 back in to the original equation up at the top. Using parentheses, 7 minus negative 23 all over negative 3, does it equal negative 10? Well, minus a negative will become plus a positive every time. So 7 plus 23 is 30, and 30 divided by negative 3 is indeed negative 10. Yes, negative 10 does equal negative 10. So it does indeed check.